Hi everybody, Dr. Pingle here. We're going to talk a little bit about charted territory and replicating analysis. So one of the easiest ways to get started learning how to analyze data is to replicate analyses that have already been done. So some of my favorite geographically related short pieces are written by Richard Middleton. He's a research scientist, but publishes this in his free time. There's a number of different articles and takes, and quite a lot of these are sort of separated by red states and blue states. So you can see that you've got a lot of scatter plots over here, often paired with an image, and he's got sort of short headlines. They go a little bit deeper than that, but that's often the general idea. If we click on the tags over here, you'll see a number of different versions of this. So you can kind of scroll through and see how many different pieces he's written. And there are, let's see, 2, 4, 6, 8, 10, 12 different pieces here. We're just going to take one. Doesn't really matter which one. So I'm going to pick this one. So this is Illuminating America, Chlamydia, and the 2016 Election. And in fact, he references this post a fair bit. So what he's got here to start with is a scatter plot, right? He's got a headline. Most of his headlines are stated a little bit more positively in the sense that he's got sort of a thesis that you can take home. So in this one, climate change beats chlamydia. So he's talking about how the relationship between what looks like a perception of whether people believe climate change is happening compares to the Trump vote. And like you would expect, that kind of breaks down by politics. In this case, though, this is this is one of his earlier posts, and we've got a scatter plot here on the x-axis, the chlamydia rate taken from the county health rankings, which we'll use, and the Trump vote. So this is just election data. The bubbles are color coded. You have to kind of dig into this a little bit, but here we are. Each bubble is an individual county. I suppose I should say that. Any counties where the state voted for Trump are color coded red. Any counties in states that voted for Clinton are blue. That's important that you keep in mind that these are counties, but they're color coded by their state value. The reason for that is if this were just by Trump vote, you would find all of these dots above here as red and all of these dots below here being blue. Right? Anything with the Trump vote below 50% would be blue. And in fact, that doesn't totally include things like well, that's the idea. Okay, so let's see what else we have here. And then bubble area is proportional to the county population. So we've got 4 different variables kind of visualized at the same time. And what he's saying is that there's a relationship here. There's a relationship between the chlamydia rate and the Trump vote, which is to say that the more chlamydia there is, the more likely it is that there was less Trump vote. So higher places that voted for Trump are more likely to have higher rates of chlamydia, and places that did not vote for Trump are more likely to have lower votes, lower rates of chlamydia. Obviously, and this is kind of the mantra in many kinds of analysis, but correlational analysis does not necessarily indicate causation. So we aren't saying that chlamydia causes people to vote for Trump or that voting for Trump causes chlamydia. But there is a connection here, probably explained by a latent variable that's almost certainly related to urbanization. You can also see a lot of the larger dots are over here, and a lot of the smaller dots are over here. So that could be a thing that you could tease out as well. He's got his observations right here. So he says that there's an R-squared value of 0.348. So you can see that in the table right here. So this is the amount of variance explained by our connection here between chlamydia and voting for Trump. So there's a 0.348 R-squared value. The correlation percentage is just the R-squared value. If you take the square root of that and include the sign, you would get that. The sign here should really be negative, but that's okay. We also see that there's a model. So this says that it's an exponential model, which refers to the type of fit that's going on here. So that's enough to get us started. And he makes a note here saying that the data were compiled and visualized using Microsoft Excel, which is how we're gonna do it. We've talked many times about county health rankings. So this is an organization that takes it upon itself to assemble a lot of the data and then distribute it back out again. So you can kind of look through the website. I always have a hard time finding things in here, but if you just Google county health rankings download, you'll often go to the right spot here. And they have a number of different pieces that you can download and look at. So here are the national county health rankings for 2019. You can go back. They've got previous years right here, so you can go all the way back to 2016. So let's just take a look at what it would take to assemble the pieces of this. So we would need 4 variables to replicate his analysis. The first variable we can actually get directly from the county health rankings. The second variable that we would need is population. So where are you going to get 2016 population data? In fact, many of these kinds of statistics can be acquired in all kinds of different places. But if I were looking for definitive population numbers, I would almost certainly go straight to the census. So if you go to the Census Bureau, go back to the TigerLine files. Oops, the census's website is kind of getting redone, so don't be too surprised if the URLs for this change a little bit. But if we dig around on here, we'll find, here we go. That's the one I'm looking for. Oh, that's the one that got moved. Okay. There we go. So this has a number of different pieces in this, and it would definitely have population values. So we'll take a look at that in a second. In fact, I'll do a lot of the downloading and assembling here offline, so that it doesn't take up time. Okay, so that gets us population, which we would need. Oops, we got to go all the way back here. There we go. That gets us the population value, which would scale the size of the circle. That gets us the chlamydia rate, which we're going to get from the county health rankings. Now we need election data. So in fact, I provided both the county health rankings for 2016 and the countywide election data in a shapefile, in a geodatabase, since many of you are going to need that data. But where could we get that election data? Well, it's kind of all over the web. We had talked about a number of different places, and I believe that I had you look for these things by GitHub. There's a nice repository here that includes a number of these different pieces assembled. There's also a website that MIT puts out that includes a number of different resources about election data. So you can certainly look through a lot of these and find what you're looking for that way. So that's another nice resource. And then the last bit here you'd need, because each of these lines is color-coded by, there we go, each of these points is color-coded by the state value. You'd also need state election results. So those are going to be the 4 pieces that I'm going to assemble. I'll pause the video here and put those together, and we'll talk about the analysis in the next section.